Well, for question 7, I'm going to use a long division method. And we've got to divide this cubic here by x plus 2. So my method is to write x and plus 2 along the side here. Now we're trying to get x cubed here, so the only thing that can possibly be is we must start with an x squared, because x squared times x gives the x cubed. Now, as a side, why does that keep doing that? There you go. As a side thing, we've got x squared times 2, and that gives us 2x squareds here. Now we don't want 2x squareds, do we? We want 3x squareds. So that means we must have another x squared here. How do we get that? Well, x times another x gives us that x squared. As a byproduct of that, you get x times 2, so you get 2x's here. We don't want 2x's, we want 3x's. So there must be another x here. X times 1 must give the x. As a byproduct, we've got 1 times 2, which is 2. We don't want 2, we wanted only 1. So we have to have a remainder of minus 1 to get from 2 down to 1. So the quotient is this bit here, x squared plus x plus 1, and the remainder is minus 1. And you could check that by putting minus 2 into it, and you'd find out that you've got minus 1 on the end. Let's do it again. We've got an x minus 2 here, so I'm going to write x and minus 2 down the side. And again, I need an x cubed, so the only way I can get an x cubed in this box is to have an x squared up the top here. The byproduct this time is x squared times minus 2, which is minus 2x squareds. That's actually exactly what we wanted. So we don't want anything here at all. So we can put nothing up there. That means there's no x's to sort out. It means we want 5 x's, so we must get all the 5 x's from here. That must mean that this number here must be a plus 5. What does that give? It gives us 5 times minus 2 is minus 10 on the end. We don't want minus 10, we want 8. So that means we're going to have to add on an extra 18. The quotient is x plus 2, the remainder is positive, x plus 5, the remainder is positive 18.